Francis Bacon stands as a towering figure in the history of science and philosophy. Born in 1561, this English scholar, statesman and writer helped to usher in the era of modern science. His emphasis on observation, experimentation and inductive reasoning revolutionized the way we acquire knowledge. Bacon's ideas continue to shape scientific inquiry and our understanding of the world today. Bacon's contributions to science are multifaceted and profound. He challenged the traditional reliance on ancient authorities and championed a new approach to knowledge based on empirical evidence. Bacon argued that true understanding comes from careful observation of the natural world and the systematic testing of hypotheses. His groundbreaking works, including Novum Organum and The Advancement of Learning, laid the groundwork for the scientific method and continue to inspire scientists today. Francis Bacon was born into a prominent family in London, England. His father, Sir Nicholas Bacon, held the high office of Lord Keeper of the Great Seal. This position placed him in charge of the Great Seal of England, a symbol of royal authority. Bacon's mother, Anne Cook Bacon, was known for her education and piety. She instilled in her son a love of learning and a strong moral compass. The young Bacon received a privileged education, attending Trinity College, Cambridge, at the age of 12. He excelled in his studies, mastering Latin, Greek, and the classics. However, Bacon's time at Cambridge also sparked a critical spirit in him. At Cambridge, Bacon encountered the dominant intellectual tradition of his time, Aristotelianism. Aristotle, an ancient Greek philosopher, had developed a comprehensive system of thought that influenced Western learning for centuries. While Bacon respected Aristotle's intellect, he grew increasingly dissatisfied with the philosopher's approach to knowledge. Bacon argued that Aristotle's method, which relied heavily on deductive reasoning and the acceptance of established truths, hindered scientific progress. Deductive reasoning, while useful in logic and mathematics, proved insufficient for understanding the complexities of the natural world. Bacon believed that true knowledge could only be attained through a different approach, one grounded in observation and experimentation. Francis Bacon proposed a radical departure from the Aristotelian tradition. He advocated for what is now known as the empirical method. This approach to knowledge emphasizes observation, experimentation, and inductive reasoning. Bacon argued that scientists should not rely solely on the pronouncements of ancient authorities or on abstract reasoning. Instead, they should collect data through careful observation and experimentation. This data would then be used to formulate hypotheses or tentative explanations for the observed phenomena. These hypotheses would be further tested through additional observations and experiments. Through this iterative process of observation, hypothesis formation, and testing, scientists could arrive at a more accurate understanding of the natural world. Section 5, Novum Organum, a blueprint for scientific inquiry. In 1620, Bacon published one of his most important works, Novum Organum, or New Instrument. This book outlined his new method for acquiring knowledge. Bacon argued that the human mind, when approaching the study of nature, is prone to certain biases and errors. He identified 4 categories of these errors, which he called idols. The idols of the tribe referred to biases inherent in human nature, such as the tendency to perceive patterns where none exist. The idols of the cave represented individual biases based on personal experiences and upbringing. The idols of the marketplace arose from the limitations and ambiguities of language. Finally, the idols of the theatre stemmed from blind adherence to dogmas and established systems of thought. Section 6, the advancement of learning organizing knowledge for progress. Bacon's commitment to advancing human knowledge extended beyond the realm of scientific inquiry. He also recognized the importance of organizing and disseminating knowledge effectively. In 1605, he published The Advancement of Learning, a work that explored the different branches of human understanding and proposed a more systematic approach to education and research. Bacon divided human knowledge into 3 categories: history, poetry, and philosophy. History encompassed all knowledge based on memory, while poetry referred to works of imagination and creativity. Philosophy for Bacon represented the pursuit of knowledge through reason and observation. He stressed the interconnectedness of these disciplines and argued that progress in one area could benefit the others. Section 7, The New Atlantis, a utopian vision of science and society. Bacon's vision for a society grounded in scientific principles found expression in his utopian novel, The New Atlantis. Published posthumously in 1626, this work describes a fictional island society called Bensalem. The inhabitants of Bensalem have embraced science and technology, using their knowledge to improve their lives and create a just and prosperous society. At the heart of Bensalem lies Salomon's House, a research institution dedicated to the advancement of science and technology. Scientists at Salomon's House conduct experiments, explore new technologies, and work to apply their discoveries for the benefit of humanity. Bacon's depiction of Salomon's House reflects his belief in the power of collaborative scientific inquiry and his conviction that knowledge should be used to improve the human condition. Section 8, A Life of Service and Controversy, Bacon's political career. In addition to his intellectual pursuits, Francis Bacon led an active political life. He served in the Parliament of England and held various government positions, eventually rising to the prestigious office of Lord Chancellor. As Lord Chancellor, Bacon played a key role in shaping English law and politics. However, Bacon's political career was not without its share of controversy. In 1621, he was accused of corruption and charged with accepting bribes. Although Bacon maintained his innocence, he was found guilty by his peers in Parliament. He was stripped of his titles, fined heavily, and briefly imprisoned. The scandal tarnished Bacon's reputation but did not diminish his intellectual contributions. Section 9. Bacon's enduring legacy shaping modern science and thought. Francis Bacon's influence on modern science and thought is immeasurable. His emphasis on observation, experimentation, and inductive reasoning laid the groundwork for the scientific revolution of the 17th century and continues to shape scientific inquiry today. Bacon's ideas inspired generations of scientists, including such luminaries as Isaac Newton and Robert Boyle. Bacon's vision of a world transformed by science continues to resonate in the 21st century. His emphasis on the practical applications of knowledge has driven innovation and technological advancement in countless fields, from medicine to engineering to communication. Bacon's legacy is evident in the countless ways that science has improved our lives. Francis Bacon's contributions extend beyond the realm of science. His writings on philosophy, law, and politics continue to be studied and debated by scholars today. His insights into the human condition, the nature of knowledge, and the importance of a just and equitable society remain relevant and thought-provoking. Francis Bacon's legacy is a testament to the enduring power of ideas and the transformative potential of the human mind.